Welcome everybody to this webinar about how hybrid workflow drive efficiency in manufacturing processes. So my name is Juliette Combe. I am application engineer at Formlabs. I conduct research on workflow on how to use 3D printed parts in manufacturing and in engineering. And this is going through internal testing and collaboration with users. So the agenda for today will be first an introduction about Formlabs for those who don't know the company, an introduction about hybrid workflows and what are the benefits of those workflows, and some example of manufacturing tools 3D printed. So custom jigs and fixture, short run molds and dies, and 3D printed patterns. All right, so just a quick introduction about Formlabs. For those who don't know us, sorry if you already know the company, I'm just gonna be quick. So we are a company that manufactures 3D printing solution. So 3D desktop 3D printer with the post-processing solution and the materials. We are about 600 people with 6 different offices. The headquarters is in Boston and the European headquarters is in Berlin. We have 3 factories, more than 150 engineers and scientists, also including material science scientists because we are manufacturing the material as well. And we've sold more than 50,000 printers around the world. So here's our product line. Our core product is the Form3 and Form3B. They are desktop stereolithography printers, so using the stereolithography technology that I will refer to as SLA. We also have a large format of these that is 5 times the build volume. And we have also a technology called Fuse One using the SLS selective laser sintering technology. But today I'm going to talk in particular on about stereolithography and what we can do with SLA part. So very quickly, SLA is a resin-based technology, which means it uses the power of a laser placed in optical unit under in the bottom of the machine, and the laser comes solidify a liquid resin and layer by layer form the part. So the advantage of SLA is that it is producing very fine details and very small surface, one of the main advantages. We are, as I mentioned, we are manufacturing our materials, so we also produce a lot of different SLA material. We have a library of over 25 materials with different mechanical property, thermal property, biocompatibility as well for medical application. So it's really open up a broad range of applications. So in terms of applications, if you think about 3D printing today, it is mostly used for rapid prototyping, which is the fast fabrication of prototype. So it really enables and allows engineers and product design to iterate on a design in a matter of hours. So if you're familiar with 3D printing, you know that you can print a part in just a few hours and really test the design and the capability of your parts. So this really helps fasten the product development. Secondly, you may think about 3D printing being used to produce small series of custom parts. So for example, we've had a partnership with Gillette to launch a limited edition of custom razor handle. In the dental or in the healthcare market also, we're doing customized series, obviously customized to the body of the patient. So here, the freedom of design that 3D printing allows is critical and allowed to do customized things. So for additive manufacturing, one of the great advantages that I just mentioned is design freedom and speed. So the desktop 3D printing is also adding ease of use to that. So desktop 3D printing like the Form3 are has a very small footprint, require very limited equipment. It's quick and easy to install, to operate, and to maintain. So it also brings flexibility to your workflow and to how you manage your equipment. And if you think about, in contrast, if you think about traditional manufacturing and traditional method, this will be much more suitable than 3D printing for large volume production. It also offers a broad range of material like common thermoplastic or metal or composite parts and so on. And the blockers in traditional manufacturing will be more like in the tool fabrication. It's often slow and expensive. So it's interesting to have in mind that additive manufacturing is not aimed to replace traditional manufacturing. We should not think about it as a replacement, and we should not try to replace the technology in the workflow for traditional manufacturing, but more to use it as a tool. So if we can combine the flexibility of 3D printing for tool fabrication, for example, with the strength of traditional manufacturing method for production, then we can really have more agility in our process. So this is what we call the hybrid workflow, using 3D printing parts as a step in the manufacturing process that you're using in your traditional manufacturing process, in order to enhance the process. So it's really, hybrid workflow is about leveraging the flexibility of 3D printing, desktop 3D printing in particular, in traditional manufacturing processes. And with that, manufacturer can benefit from the speed and the flexibility of in-house 3D printing to create tools like jigs, molds, dies, just in a couple of hours, and combine it with the production force of the traditional method. So this is all in the goal of doing agile manufacturing and be more agile in product development and in production. So I will now give you a few examples of what I'm talking about. This is an overview of how our customers are using 3D printing in manufacturing with hybrid workflow. For each of these applications, we have some specific webinars and white paper. So I'm not going to go too much into detail, but feel free to ask questions or to ask for more detail, and we can also send the white paper and the webinar for each application. So first, I want to talk about using 3D printed jigs and fixture in the factory. So in the factory floor, we have an example of customer that is called Penkel, that is in Austria. And they are producing drivetrain. They are an automotive supplier, and they needed custom jigs in the assembly line, and each jigs was custom. And by using 3D printing, and in particular our tough resin that you can see here, this is the blue part in this video, they managed to reduce the cost by 80% and the lead time by 80% as well. So this, for them, was really a game changer. Another example is this company called Acropress, which is a US company that makes high tonnage machine for metal bending and shearing. And they also use the tough resin for replacement parts. So to specifically here to replace an angle gauge device. So this is another example of how to use 3D printed parts as jigs, fixture, or replacement parts in your factory. Obviously, the possibilities are endless. You can really do a lot of things with it. I just showed two examples of our tough and durable resin family, which are material that had interesting mechanical property. They can handle compression, stretching, bending, and impact. So they are actually very popular among our user base for this application of gypsum fixture. Another example will be this time to quickly print dies in-house for forming sheet metal parts. So this is pretty new, and it's also not very intuitive to use plastic printed parts for forming metal parts. But it's actually a project that has been done with one of our lead engineer in intern, and that show great results. So we also have a white paper about that and a webinar that is explaining a bit more the method. And he printed 3D printed dies with our rigid 4000 material. And just in a matter of hours, he could actually place the 3D printed part in an hydraulic press and use it to form a sample gauge for sample blade guard, for replacement parts in his workshop. So that was a huge time saver and money saver. So you can see the video here of the part being pressed. And what is interesting in this design is that he could both form the internal feature that you can see here on this video and bend the flange with these dies. So those are two forming operations that are quite common and that are really useful to be able to do with 3D printed dies. The material used here was from the family rigid that is our stiffest material that proposed two different materials. So they are not the only material you could use for a forming operation, but for this one, because it has a very low speed, it was a really good one. If you will do, for example, embossed parts, so you will need a material that has more impact strength, and maybe that you will prefer tough material that I introduced right before. All right, another application I want to talk about is molding. So using 3D printed mold to quickly produce small series of common thermoplastic with injection molding. So injection molding is a very popular application. We've been working on it a lot lately. We have a webinar, a white paper, and we have a lot of users that gave us feedback and share knowledge about that. So I want to tell you a little bit more about it. So it's critical to understand that we should not expect the same performance from a 3D printing polymer mold than from a metallic one. It has critical dimensions that are harder to meet than with metal. Cooling time is longer because the thermal transfer occurs slower in plastic than in metal. And printed mold can easily break under heat and pressure. However, as I've just said, some companies manage to achieve a small series of hundreds of parts with a printed mold and even thousands of parts for a very simple design. So here's the first example of a company called Braskem. They are a supplier of material, supplier of thermoplastic, based in the US, based in Brazil actually, but we were working with the company based in the US. And they run 1,500 injection cycle with one printed mold. What was interesting here is they also used a printed insert that they directly slided into the injection molding machine so that they could really have the printed part that carries the geometry and a metallic frame in the machine that hold the strength of the process. So here are some numbers. They were using an electric press, Cincinnati, so an industrial press machine, and they were producing parts. They start producing parts in 4 days, so they managed to iterate the mold very quickly. They did 3 design iteration, and they ended up having, as I mentioned, 1,500 injection at 30-second cycle time. And they were injecting polypropylene at 230 degrees. So this is really a great result. You can see here the geometry that they were producing. It's a pretty simple design, so more complicated design will be harder to inject, but in the design, in the white paper that we just released, we also have some design guidelines to help understanding how to limit the pressure inside the cavity. So another example, oh, I'm missing one slide. All right, then I'll just discuss on this one. Another example that I will jump directly to this one. Another example that I want to mention is from Nodus Fabrication, which is a company based in the US that were also producing a 3D printed mold and fabricate hundreds of parts with a mold printed with high temp rigid, with rigid 10K, rigid 10K resin. And this is interesting because he was looking at a much more complicated design with a sided action core and an internal thread that you can see on this picture that are pretty delicate to inject. So for 3D printed mold, you can have mold breakage much more easily with this kind of geometry. And he actually managed to do a series of hundreds of parts with 50-second cycle time, also injecting polypropylene. So you can also see that he was printing the main design in the printed material and placing the mold inside the metallic frame. And a last example is from a customer, Holy Maker, that is proposing a desktop injection molding machine, which is a great solution if you're not familiar with injection molding, but you would like to start. And you would like to start doing it on the desktop, for example, producing a series of prototypes. So if you have identical prototype to produce in the final material, this is a great way to do it. And he was using our Grey Pro resin, but you could also be using rigid 10K, for example. All right, so that was for injection molding. Last application I want to discuss is an example to open new materials. So we have customer using a 3D printed mold to fast fabricate carbon fiber, so to do carbon fiber lamination on 3D printed mold. So an example of the TU Berlin. So the FAST2B, the Formula student team of TU Berlin, is using the Form 3 printer, and they fabricate carbon fiber parts through hand lamination on TUF 1500 molds. So you can see here they were using that for fabricating the steering wheel of the car, the grips, as well as the housing. And they managed to reduce the weight greatly with this method from a previous method. And they chose TUF 1500 because it's a resin that is easy to demold, that gives a bit of softness, and they could demold easily and actually do new geometries that would have been difficult to mold otherwise and to demold otherwise. Another example is from Delta Wing Manufacturing that also fabricate carbon fiber parts, but this time with pre-preg lamination on a high temp mold. So high temp is one of our materials that can handle very high temperature. And this is really suitable because the pre-preg lamination process has a very high temperature and pressure condition. So they were able to laminate on this 3D printed mold directly to go on the Formula 1 racing car. And the last example I want to show is printing patterns. So again, Delta Wing, actually the same project, was either directly printing or printing pattern. So this is a great tool when you want to scale production, when you want to do multiple molds, or if the mold is will have to handle intensive process, and that the 3D printing mold will not be a great choice. So we have a lot of users that print the pattern before making the mold. This is also used in direct investment casting and sand casting. So this is an opening to show what is feasible. All right, so that's it for me. Thank you very much, and I think now we have a Q&A session. I'm happy to answer any question you may have.
Yes, exactly. Thank you very much up to this point for the presentation. Well, if you have any questions right now, please do not hesitate to enter them in the question box so that Ms. Combe can answer them. But I can, right now, I cannot see any questions yet, but we will just wait a little bit longer to give you time to enter your question. Of course, you are welcome to ask any questions after today's presentation as well. You can visit the Formlabs homepage, for example, or you can use the web session homepage where you have registered for today's presentation. There is also the opportunity to write a message and we will forward them. This is also possible, but as I said before, you have now the opportunity to write any question in the question box. But at the moment, I can still not see any questions, but just a little longer we will wait. Okay, but I cannot see. Oh, okay, I can see now the first question. I can just read it out, Ms. Combe, and you will give the answer, if this is okay?
Yeah, sure.
Okay, the question is, do you have more examples for 3D printing jigs or fixtures?
Yes, actually, we have a lot of examples, also using different material. So I'm happy to send a guide afterwards on 3D printing jigs and fixture with more example. We have, for example, a research center in the UK that was using jigs and fixture to replace robotic grips. This was used actually in different occasions. So one was for the application of applying carbon fiber plies on the robotic grips. We also have an example of Ashley furniture in the US that were using inside the factory jig and fixture for work holding. So any type they had to assemble a part, they were using jig and fixture to hold the work. So I'm happy to send more detail afterwards on that. We have a lot of case studies.
Okay, thank you for this answer. And I can already see a second question. And it says, do you have to think about tolerance when printing a mold in rigid 10K? Is there a difference between CAD and model?
So yes, it's a great question because it's quite important to think before you print that your model will have not perfect dimensional accuracy. So it's pretty good actually. Our users are pretty happy about it, but what we recommend is to give a little bit of extra stock in the mold and then hand sand it at the end so that you have the perfect dimension that fits. But usually model, like critical molding surface, don't need to be hand sanded, but it's more like to fit both half of the mold together and fit it in the metallic frame.
All right, so thanks again for the answer. And that's for the open questions right now. We will just wait a couple more seconds to give you time to enter more questions. But as mentioned before, you are welcome at any time to ask any questions after today's presentation. This is also no problem. But I think right now we have no more open questions. So I think everyone seems to be happy and satisfied. Ms. Comp, you can now address a few final words to the participants and say goodbye, if you want.
Perfect. Yeah, thanks a lot, Martin, and thanks everybody for joining and for listening to me. It was a pleasure.